Hello my dear children, welcome back to the lecture series of Maharashtra Board Chemistry, Grade 12. Name of the topic is Alcohol, Phenols and Ethers. This is a third video where we are going to discuss about the chemical and physical properties of alcohols. In the previous videos we have already discussed about the introduction, classification of alcohols and nomenclature and preparation of alcohols. These four topics are already covered. Today we are going to start with the physical properties of alcohols. My name is 𝐒𝐿𝐵𝗲𝗃 and you are watching 𝐿𝐵𝗲𝗃 classes. Let's get started. So in the physical properties of alcohols, the first physical property which we need to know is nature of intermolecular forces. So we know that in alcohol there is one oxygen present and hydrogen is also present. So if there is, we already know that if there is hydrogen present and fluorine, oxygen or nitrogen, either of these elements are present, there will be a bond, special type of bond which is called as hydrogen bond, right? So in alcohol we can see, we can see that this is your one molecule of alcohol which is having hydrogen bond. This is a hydrogen bond with another molecule of alcohol, ROH, which will be having hydrogen bond with another molecule of alcohol like this, HOR, and same thing will keep on going. This is called as intermolecular hydrogen bonding. Okay, so alcohols are polar molecules. Polar molecules, why? Because oxygen is delta negative and this carbon will be delta positive. So these are polar molecules due to OH group. Because of OH group present over here, even this hydrogen is delta positive. Alcohol molecules are bonded together due to hydrogen bonding. So there is a special type of bonding present in alcohol molecules which keeps them in associated form, which is your intermolecular hydrogen bonding. Next physical property is physical state. Next physical property is physical state. So lower alcohols are colorless, toxic liquids having characteristics alcoholic odor. We just have to know this much. In boiling points, we already know that boiling points is directly proportional. Boiling point is directly proportional to molar mass. Okay, and also boiling point is directly proportional to surface. So, as per these two factors, boiling point which is directly proportional to molar mass and which is also directly proportional to surface area, boiling points of alcohols increases with increase in molar mass. If the molar mass of the alcohol increases, that is for higher alcohols, boiling point will be more. Also, if the surface area increases, boiling point will be more. Come to the next physical property which is solubility. So with lower alcohols having up to 3 carbon atoms, they show appreciable solubility in water. Normally we know that water is a polar solvent which will dissolve polar compounds, and alcohols which is non-polar, it is basically organic compound. So it should not be dissolved in water, but they are dissolved in water or they are soluble in water because of the ability to form intermolecular hydrogen bonding with water. So how we can show this? Suppose this is my alcohol molecule. I'll just show it like this. This is my alcohol molecule ROH. This will be forming, this is your water molecule, this is one of the water molecule, this is another water molecule, and this alcohol molecule will be forming hydrogen bond with water molecule like this. And because of this property, because of this intermolecular hydrogen bonding, alcohols will be, lower alcohols up to 3 carbon atoms, they will be appreciably soluble in water. So now we'll discuss about the chemical properties of alcohols. The first chemical property is the laboratory test for alcohols. In this, the first test is litmus test, which shows no action. That means the blue litmus will not change the color, red litmus also will not change the color. That means that alcohols are neither acidic nor basic and they are neutral. Second test is alcohol plus NaOH, and we get no reaction. That means NaOH is a base. With the base, alcohols show no reaction. That means they don't show in any acidic property. Third reaction, alcohols plus Na, reaction occurs and alcohol show acidic character. Now here what happens, see, we know there is a reaction of acid where acids react with active metal to produce hydrogen gas. For example, Mg plus HCl gives you MgCl2 plus hydrogen. So this is a property of acid. Hydrochloric acid is an acid. When it reacts with active metal, it liberates hydrogen gas, which is a property of an acid. Or with this reaction, any substance which shows this reaction will be having acidic property. Now see here, alcohol react with Na. Na is active metal. There is a reaction, and what is the reaction? This alcohol reacting with Na, which is active metal, and it is forming RONA, which is called as sodium alkoxide plus hydrogen gas. Since it is producing hydrogen gas with active metal Na, therefore alcohols are considered to be acidic. But the acidic property of alcohol or the acidic strength of alcohol is very, very less, because you can see that they are neither showing positive test for litmus, neither they are reacting with base. So the acidic property of alcohols are very less. They are very weakly acidic in nature. Now we move on to the next type of reactions, that is the reactions due to breaking of OH bond. So here we are talking about the reactions where the OH bond, this bond OH will be breaking here. So this will also show the acidic character of alcohol. So this is your alcohol. This is basically alcohol. Okay, I am writing it here. This is my alcohol and this is water. So when alcohol reacts with water, okay, alcohol liberates the hydrogen and it forms RO minus, and this hydrogen will be taken by water molecule to give you hydroxonium ion. Now this reaction is how much feasible or how well this reaction will go on. This is we can see that if this is suppose acting as an acid, since it is giving H plus, therefore it is acting as an acid. So RO minus will be the conjugate base. Now see the stability of conjugate base. The conjugate base is not stable because there is a minus charge on the oxygen, and this R group is having plus I effect. That means it is pushing electrons on oxygen. So the electron density on oxygen will be increasing, which will lead to the instability, right? So this conjugate base is not stable. That means this reaction will not go towards the forward direction. So alcohols do not react with water, that is do not ionize with water. That means it is not showing the acidic character. Next reaction is esterification. The meaning of esterification is ester formation. So ester is formed when alcohols react with carboxylic acids, acid halides or acid anhydrides. So alcohols might react with carboxylic acid or acid halide or acid anhydrides. They will form ester, and this reaction is called as esterification reaction. So if I write it this way, alcohol, my substrate is alcohol. If this alcohol react with carboxylic acid, okay, one of the reaction will be with carboxylic acid or acid chloride or acid anhydride. In these three cases, they will give rise to ester, and this reaction is called as esterification reaction. So see, this is my alcohol ROH and this is R-COOH, which is our carboxylic acid. So from the carboxylic acid OH and from the alcohol H will be liberated. So water molecule is liberating over here, and rest of the part you just join. So you get ROCOR dash, which is your ester. So now the second reaction, alcohol, and this is acid anhydride, okay, R-COOCOR dash, this is acid anhydride. The reaction occurs in presence of sulfuric acid, so we are putting H plus over here. What is happening again, this is suppose minus and this is suppose plus, okay. Now break this bond. If you break this bond, this oxygen gets a minus charge and this carbon gets a positive charge. So this negative charge you attach with the carbon and this positive charge you attach with the oxygen. So you get R-COOH that is your byproduct R-COOH. Another product is ROCOR-, which is your ester. So here alcohol reacts with carboxylic acid. This reaction I showed you, okay, and alcohol reacts with acid anhydride. So this reaction I showed you. These are the two reactions where alcohol reacts to carboxylic acid and acid anhydride to give you ester. Another reaction is with acid chloride. So the acid chloride is this, RCOCl. This is the acid chloride. In this reaction, HCl comes out. HCl comes out and the reaction happens in presence of pyridine. Pyridine is a nitrogenous base. Okay. So the rest of the things you join, so you get ROCOR-, and HCl. This is my ester. So this is your esterification reaction. By the same reaction, if you want to get phosphorus, alkyl bromide or alkyl iodide, then our reagent will be red phosphorus with Br2. So basically, PBr3 is formed out of these two reagents. You can see the reaction over here. P4, which is my red phosphorus. P4 is my red phosphorus. Red phosphorus reacts with Br2 to give you PBr3, phosphorus tribromide. This is a balanced equation for that. So we are not adding PBr3 directly in the reaction. Instead, we are adding red phosphorus and Br2 in situ, that is inside the reaction mixture, along with alcohol. These two first reacts to give you PBr3, which is our main reagent, and then this reacts. So PBr3, so it will give you CH3Br. So we are getting 3CH3Br, which is methyl bromide. This is our main product. And since we are using trihalide, therefore the byproduct is phosphorus acid. I already told you how it is coming in the previous slide. Now this is again methyl alcohol and we want to produce methyl iodide. So now our reagent is Pi3, which is obtained from red phosphorus and Br2 in situ. In situ means inside the reaction mixture. We get methyl iodide as the main product, methyl iodide, and since we are using phosphorus trihalide, therefore the byproduct is phosphorus acid. The reaction is dehydration of alcohols to alkenes. So here alcohols when treated with concentrated H2SO4 or phosphoric acid or alumina, all these three reagents are dehydrating agent. What do you mean by dehydrating agent? Dehydrating agent. So here D means no or removal, hydro means water. So no water, or you can say removal of water. So these three reagents, they will help in removing water because they are called as dehydrating agent. So alcohols when treated with concentrated H2SO4 or phosphoric acid or alumina undergoes dehydration reaction to form alkene and water. The reaction gives more substituted alkene as a major product in accordance with 𝐔𝐤𝐝 rule. Okay. So if this is my alcohol, this is called as ethyl alcohol. This is an alcohol with 2 carbon atom. You are putting concentrated H2SO4. So the carbon atom where the OH group is attached, where the functional group is attached, is called as alpha carbon, and this carbon is called as beta carbon. So this reaction is also called as beta elimination. Means what? From the beta carbon the hydrogen will be eliminated and from the alpha carbon OH will be eliminated. So water molecule will be eliminated. This is the way water molecule will be eliminated, and these two bonds will combine together here to give you a double bond. So we are getting ethene as our product here, ethene as a product, and water molecule which is removed. Same reaction if we, this is here we are getting us, this hydrogen is removed or this removed or this removed, you get the same product. So there is no problem. But if we have a substrate like this, which is this is called as butane 2-ol. Okay. Now this is alpha carbon, this is beta carbon, and this is also beta carbon. So there are 2 different beta carbons, and therefore there are 2 different types of beta hydrogens. So if this hydrogen is removed, from this carbon hydrogen is removed, we get a double bond in between these 2 carbon. And if this is removed, we get a double bond in between these 2 carbon. So according to this, we get 2 different products. First, if the hydrogen removes from this carbon, so we get a product as CH3 CH double bond CH and CH3. I hope you understood. I'll just draw it like this. CH, suppose this is H, this CH2 I wrote it this way, and this H and OH is removed, so we get a double bond over here. This is your but 2-ene. Okay, and if it happens like this, now I'm rubbing this part, CH2, this is OH, CH2, and now if this hydrogen is removed, I will write this as CH2 now. If this hydrogen and this OH is removed, we get a double bond over here. So according to the product is CH3, CH2, CH double bond CH2. So when we get these two products, it has been seen that this is the major product according to 𝐔𝐤𝐝 rule, and this is the minor product because this is the more substituted alkene. Now how do you know what is more substituted alkene? So I'll just tell you a simple trick. This is your carbon-carbon double bonded carbon, which is your functional group over here. So this carbon is alpha carbon and this carbon is alpha carbon, and these hydrogens are alpha hydrogens. So you can see in this molecule there are 6 alpha hydrogens. Okay, and same thing if you apply over here. This is a carbon-carbon double bonded carbon, that is functional group. This is your alpha carbon and these are the alpha hydrogens. So there are 2 alpha hydrogen in this molecule. The more number of alpha hydrogen, more is the stability. Understand that. Or you can say the more number of alpha hydrogen, it is a more substituted alkene. So according to that, we can understand this is the more substituted alkene, which will be the major product in this case. Last reaction of alcohol, that is oxidation of alcohols. Okay. Now it has been seen that for 1 degree alcohol, when primary alcohols or 1 degree alcohols react with PCC, whose full form is pyridinium chlorochromate, which is what? Which is a mild oxidizing agent. It is not very strong oxidizing agent. It is a mild oxidizing agent. So when alcohols react with PCC, they are oxidized to aldehyde. So you can see this is your RCH2OH, that is 1 degree alcohol. With the help of PCC, the oxidation takes place and CH2OH groups converts into CHO group, that is aldehyde group. When primary alcohols are treated with strong oxidizing agents, now if you are taking strong oxidizing agents like HNO3 or potassium dichromate or potassium permanganate, they are oxidized to carboxylic acid. The reaction goes via aldehyde, but you cannot stop the reaction in this state now because the oxidizing agents are very strong. So they will directly convert primary alcohol to carboxylic acid. So this is your 1 degree alcohol. Okay, when you are oxidizing with the strong oxidizing agents like nitric acid, potassium dichromate or potassium permanganate, first aldehyde is formed. So the reaction goes via aldehyde, but you cannot isolate aldehyde because it will immediately convert into carboxylic acid. You cannot control the reaction and stop it in aldehyde level. So if you want to get aldehyde from primary alcohol, you have to specifically use this reagent, that is pyridinium chlorochromate. Okay. Now for secondary alcohols, on reaction with oxidizing agents, secondary alcohols undergo dehydration to form carbonyl compounds, namely ketones. So we have RCHOHR. This is your secondary alcohol. CHOH is your secondary alcohol. You are treating this with CrO3, chromic oxide, which is oxidizing agent. Okay, and you are getting CO, that is your ketone. So primary alcohols give rise to aldehyde and finally carboxylic acid, whereas secondary alcohols on oxidation gives you ketone. Okay. This is again oxidation reaction of alcohols, but it is with different reagent. Here we are oxidizing alcohols with heating with copper. Okay, so heating with copper, when vapors of various types of alcohols are passed over hot copper, the following reactions are observed. This is your 1 degree alcohol. When the vapors of this alcohol is passed over heated copper, the temperature you can see, this is 573 Kelvin, you are getting aldehyde. So 1 degree alcohol gives rise to aldehyde. That means this is not a very strong oxidation process. The reaction stops at aldehyde level. Next, this is your secondary alcohol. CHOH means this is your secondary alcohol. When you do the same reaction with secondary alcohol, you get ketone. So primary alcohols convert into aldehyde, secondary alcohols converts into ketone. Just remember the reagent, that is copper along with 573 Kelvin temperature. This is your tertiary alcohol. You can see this is COH. COH means tertiary alcohol. It is the same reaction is being done, and now it is the dehydration process is going on. One of the hydrogen from here, I'll just write it this way. This is CH2 and suppose this is H. So what is happening is this water molecule is coming out from here, and there is a double bond between this carbon and this CH2. So we get alkene over here. Okay, so tertiary alcohol will not give rise to any oxidized product. It is instead it is undergoing dehydration reaction and forming alkene. Okay, so here we have completed with all the reactions of alcohols. Now in our next lecture, I'll be coming up with the phenol part. Since this chapter is, there are 3 different compounds, alcohols, phenols and ethers, and we are doing all the 3 different compounds separately. So in today's video, we have completed with alcohols. The uses part you can just go through. So in the next video, I'll be coming up with phenols. Thank you so much. If you feel these videos are beneficial to you, please subscribe the channel and press the like button. Stay tuned.